Good afternoon and welcome to these CWIEME Tech Talks about the future of electric motors in a changing electrification landscape. I'm Alexandra Martins and I'm CWIEME Berlin's Senior Content Manager. We are delighted to have you all here joining us today. Hope you enjoyed the presentations and connecting virtually with your peers. Before we get started, I would like to quickly go over a couple of housekeeping points for this session. If you have any questions, please add them in the comments. This webinar will be available on demand after the session. The slides can be downloaded from our website. I'm pleased to introduce our speakers. Michael Southcott, Manager Electrification Technology Research, Kartik Ganesh, Principal Analyst Electrification Technology Research, and Daniel Berumen, Senior Analyst Electrification Technology Research at S&P Global Mobility. I will now hand over to our speakers. Welcome, Michael, Kartik, and Daniel.
Hi everyone, thanks Alexandra, and thanks for the introduction. And yeah, great to be here again for another session with yourselves. And yeah, as you mentioned, we'll look at the landscape of the electric motor. We'll try and focus in on the three key regions of Europe, North America, and Greater China, and also get a bit of an industry overview to kick things off. So, what we'd like to do, I'll kick things off, start looking at the industry sentiment and a bit of the global overview on the current e-motor market and where things stand. So first, before we dive into the sort of e-motor data, I wanted to show this. This is from our consumer survey that we run here at S&P Global Mobility. This tracks, it's around 30 plus thousand surveyors throughout the year. And it covers a whole raft of questions around the changing automotive landscape. A big section of it is around the e-mobility transition and the transition towards battery electrics and hybrid. I think what we wanted to highlight here this year in particular is that the consumer sentiment, ever since we came out of the post-COVID world in 2021, we had big industry investment into this transition. The big sentiment was there amongst consumers. We'd seen the sort of, let's say, the air quality, the pollution levels that we could have if we can clean up the big cities globally. And sentiment was really high. Over the last 3, 4, 5 years, it's trailed off and it's declined. What we did see last year in 2024 was an uptick in hybrid. That hybrid sentiment where it met the middle ground between the combustion engine and the battery electric vehicle. We saw the uptick to about 75% of people were open to purchasing one. That's declined this year by 6%. Quite a big drop off and quite a surprise for us. One of the big reasons highlighted on the right, the three big reasons why we're seeing people not purchase this, and for the hybrid in particular, it was the cost. The price of that hybrid vehicle still amongst consumer sentiment globally remains too high for people willing to switch over and purchase. Charging experience, let's say time, availability is still the big one. And range as well. That range anxiety has not gone anywhere amongst consumers and their willingness to switch over, particularly to battery electric. But let's focus in on the electric motor itself. So traction motors only in this presentation. So everything that's got a sort of a PX definition across the spectrum of mild hybrid up to battery electric. If we look here, and probably when we did this webinar towards the end of last year, and certainly when we were at Berlin, sort of in the early parts of 2024, the big uptake of BEV has not diminished. It's still the predominant technology of choice for motors being produced, but its presence has diminished, let's say, when we look towards the end of the forecast. We were previously looking at about 2/3 of all motors produced sort of mid part of 2030s were going to be used in battery electric vehicles. That's diminished down to about 45%. So still pretty big, still the big markets, in particular Greater China. But what we're really seeing now in the industry is this emergence of alternative technologies. Plug-in hybrids remains a big one, particularly in North America now. We have the full hybrids, which a lot of the Japanese suppliers and OEMs never went away from. And we have this emergence of range extender. So the flip-floppers, I would say, of a plug-in where you have a small battery and a big engine. Here you have a much bigger battery and then the smaller generator engine. The overall, what we're seeing from where we were this time last year, about 8 million more motors have been added to that top line number. So if you're an electric motor supplier, it's good news. There's more on the top line, albeit a much more varied mix around where those motors are going to be used in either the hybrid or the battery electric vehicle. And breaking it down regionally, where's the demand going to come from? So we have the big markets. We have North America, we have Europe, we have Greater China. They're approaching 14 million motors demanded this year in 2025. The one I like to focus on in particular is South Asia. South Asia is one that we really have an eye on, particularly India in that market. India is emerging as a really big potential uptick in motor demand that's going to come in the next couple of years. If we look to 2031, so it's 5 years away, give or take a couple of months now. The demand in South Asia, and like I say, a big chunk of this in India, but South Asia is going to emerge as nearly a bigger market as North America this year, approaching the size of Europe, bigger than what Japan and Korea's demand is in 2025. So really big trajectory of growth coming in the next couple of years in South Asia. We've got it in North America, Europe, and Japan, Korea, like I say, and then that big dominance of demand that comes from Greater China. I'm not going to spend too long on this. This is a reference to our version number 16 of our rapid response that we do here at S&P Global, where we focus in on the tariff situation and how it's emerging globally. We always put it in e-motor presentations. I would say when we look at the fundamentals of an electric motor, 3 commodities: steel, electrical steel, rare earth, and copper. All 3 have had a massive impact and a massive fallout from the impact of these tariffs. I won't focus too much. The guys will spend a bit more time regionally as to how that's emerging in Europe and the US, but it really has had a big impact on the electric motor this year and how we've seen that evolve and how we're seeing technology choices evolve at the OEM level and the supply chain level as well. What I wanted to focus in on, and this is just one component, this is the motor. We could go across all of the components we track here at S&P Global, but this is why tariffs were fundamentally brought in, the importance of trade globally and where these motors are being produced. So what we have here in the bars that go up, we have the demand of motors in each region throughout the years. So you can see there's that big demand in China. We've got Europe there. But then what we're looking at is a percentage of imports that's coming. So if we take the red line first here, North America, how many motors are being imported from North America? It's approaching about 50%. It's about 45% of motors that they're going to use in North America being imported from outside. And Daniel will focus a little bit more later on where those are coming from. There is already planned investment into North America. We know that there's going to be a reduction. It's going to come down to around 30% by we get to the early part of the next decade. But they want to go further. They want more investment. They want to bring that number down even more. Is that going to happen? Let's see. Probably it needs a bit more stability, and Daniel, again, will focus on that. The other one to focus on is that yellow dashed line there. So that's Europe. Europe currently is at about 20% of imports. It's kind of the opposite to most of the other regions. We're going to see more imports coming into Europe as a percentage of their demand. It's going to approach about 25, just over 25% of Europe, of motors used in Europe will be imported from other regions. Greater China is a big part of that. About 52% of the motors that are imported into Europe are coming from Greater China in 2030. And then the other one at the top, just that quick dashed line on South Asia. So South Asia, again, I touched upon it there. We're going to start to see a bit more investment in South Asia and some of the bigger countries. Like I said, I focus on India a little bit there. We're going to start to see the investment come into those regions, we think, as the demand grows. And we're going to start to see a drop in the number of motors imported there as a percentage. I mentioned rare earth. One of the big fallouts that we've had from tariffs is the impact on rare earths. We had the licensing issue with China, and it's having a knock-on effect at a global scale on the technology choices that people are making or the supply chain choices. So Kartik and Daniel already sort of explained to you the difference we're seeing in Europe and North America there. But at a global scale, if we take China out of it, because fundamentally, the abundance of magnets and rare earth that gets produced there, we think by the time we get to the midpoint of next decade, so about 2035, at a global scale, we'll be approaching about 30% of motors not relying on rare earths. So rare earth free, that could be a rare earth free magnet. It could be different technology choices like BMW or Renault have already gone down the route of some of those. So we are seeing this emerge. We are seeing it, and risk is the big word we hear. How much risk do they want in the supply chain? We saw a few OEM factories and plants have to be shut down, albeit quite temporarily this year. That risk is still inherently there in the supply chain of the electric motor, and how OEMs, how much of risk do they want to absorb here is really going to be the big question looking towards the end of this decade as they make some of these technology choices now for sort of 2028, 2029 SOP. And finally, another bit on this one as we kick it off, how we're seeing the supply chain emerge. So lots is happening, but fundamentally in the supply chain, we're seeing this emergence of subcomponents. So on the electric motor, it emerged about 18 to 24 months ago. We're seeing it on some other components now, like the inverter as well. Fundamentally, it's OEMs bringing design in-house. They want to have a bit more control over the design of these. And then we're seeing opportunities for suppliers for print to build. They're having to be flexible. They're having to keep manufacturing lines going. And they're having to look at these subcomponents of doing a print to build rotor, a print to build stator. It could be their own designed rotor or their own designed stator. Plenty of examples on the market, particularly in Greater China as well, but not just exclusively there. By the time we get to 2030, about a third of all rotors will be outsourced. So when we say outsourced, that's the motor assembly supplier is not producing the rotor. And on the stator, it's at about a quarter of the market by the time we get to 2030. The big trend we are seeing here and beginning to emerge is the presence of tier twos. Tier twos who traditionally were the stampers and the laminators producing, as we defined, the core, now going and finding a magnet supplier. Can we develop with a magnet supplier a rotor or a copper supplier, a stator, that will move us straight to be in the tier one? The OEMs have got the design in-house. Let's effectively cut out the middleman of the tier one, and let's go straight to being a tier one supplier ourselves if you were in that traditional tier two landscape. On that note, I will hand over to Daniel, who will give us a good overview of North America.
Awesome. Hello, everyone. I'm thrilled to be here today to discuss some critical insights into North America's electric motor production landscape. So let's dive right into the current situation and examine how Trump administration has reshaped this landscape. So as we look at the first slide, we can see a global forecast comparison against North America. Obviously, for e-motor production, this visual gives us a clear picture of the trends we are observing regionally. On the graph, you will notice three lines, each representing different time periods. The green-blue line is the forecast pool from November last year. This is prior to the Trump administration. The yellow line represents the forecast from April this year, showcasing the first impacts of the Trump administration. And lastly, and the most important of them, is the red line that is showing the latest forecasts. So it's incorporating the effects of the tariffs and also obviously all these Trump administration steps. So globally on the right graph, we don't see a lot of impact. Just a slightly decrease of 9% by 2028, which will diminish later. However, regionally in North America, we have quite a significant impact. By 2029, we're looking at a decrease of almost 25% on e-motor production in the region. So this translates to about 4 million units. It's important to note that when we refer to North America, we're talking about the whole region, USA, Canada, and Mexico together. So recent US tariffs, the ban on rare materials and EV tax credit gone have slowed down electrification and decreased the e-motor production on the region compared to the global production. Nevertheless, the road to electrification is still very much alive, and we have major players in North America pushing forward in the region. On this next slide, we explore the North America motor export breakdown. Here we see that while North America produces a significant amount of their production for in-house use, the demand of e-motor is anticipated to increase across various regions. However, the Trump administration policies have obviously slowed export to key markets, for example, like Europe. And it's also important to mention that if you see the graphs here, Japan and Korea region does not receive any motor from North America. Just to compare, for example, in 2025, North America is expect to export around 278,000 electric motors, while Europe exports about 1.1 million, China 1.9 million, and Japan and Korea region about 5.6 million. Now let's shift our focus to imports. North America main imports come from Europe and Japan Korea region. We can see short-term impact on imports from Europe, while there is a balance on Japan Korea volumes. Interestingly, the highest import to North America come from Japan and Korea region, even though they don't take any motor production from North America. So in comparison, North America imports around 3 million units, while Europe, China, and South Asia imports around 1.8 million units. In conclusion, we can clearly see that North America region has a foreign trade deficit, and this indicates that North America will continue to heavily rely on Japan, Korea, and Europe in this electrification landscape. In this next slide, we have a crucial topic here, Mexico as a manufacturing hub under the USMCA. Mexico's e-motor production is tailored for the North American market. In our first graph, we can see that Mexico e-motor production will increase in the coming years to satisfy United States volumes. And in our second graph, we see imports to Mexico that the imports has a similar stories. The United States is also a key player here, but we also see some volumes coming from Japan and Germany. Mexico has constantly been a manufacturing hub for North America thanks to the USMCA. However, recent tariff tensions and global challenges have impacted this growth. A key milestone is approaching. USA, Mexico, and Canada are preparing for the USMCA revision next year, and Mexico is already starting to take some measures to protect this regional agreement. They recently just announced a 50% tariff on Chinese vehicles. So yeah, we are expecting to see more of these kind of reinforcements movements during the USMCA revision to align with the regional production and supply chain. On this next slide, we're going to talk about US tariffs and trade agreements punctually. Overall, the automotive industry needs to adapt quite rapidly. And as Michael already mentioned, the motor industry is fundamentally underpinned by three commodities that are rare earths, electrical steel, and copper. So recent actions have introduced different degrees of risk into the supply chain. One significant factor is China's rare earth export restrictions, particularly on 7 rare earth elements that are crucial for high performance magnets like dysprosium and terbium. And license for these restrictions must now be approved so China can deliver RERs to USA, taking around, the approvals take around 45 days for this. The first license that were given take place that were given for this citation were around May. So they are about to end or have already ended. So they will need to get a new license. And it's interesting to mention that during August, China export to the US reached a 6-month high. So we can imagine that the industry is trying to load their warehouses to prevent any downtime. Therefore, government pressure and communication will be essential moving forward. The second factor is the electrical steel contained in every electric motor car. The electrical steel is already subjected to a 400% tariff in some cases. And the third and last factor is copper. Implications for copper are still unclear. There is already a 50% copper tariff that is trying to balance the difference between what is produced inside and outside US. The industry is already exploring various solutions to mitigate this potential supply chain problem, with important trends toward reducing dependency on these crucial rare earth materials. On this next slide, we're going to see how this tendency are taking North America. So looking at the global rare earth free motor penetration, we see an increase from 14% in 2025 to 23% by 2037. This is primarily driven by Europe. In North America, however, this penetration remains relatively flat, moving from 18 to 21%. Induction motors are expected to find a major use in as secondary drivers and in different applications apart from light vehicles, for example, pickup and vans. With market volumes in 2037 projected to be 5 times those in 2025, we can clearly see this uh, increase in volume. ESMs are also projected to gain volume as primary drivers, while high-performance variants will continue to utilize the permanent magnet synchronous motors for both primary and secondary drives. Additionally, the success of magnets production lines in North America and the quality of these lines will be important to determine whether these volumes can help slow down the shift towards ESM technologies or motors without rare elements. On our next slide, with the anticipated growth in EVs, North America is projected to demand over 11.4 million EV drive units by 2037. E-beams are essentially solid beam axles that we can find in ICE vehicles, but featuring an integrated e-motor in the axle. Different applications like pickups, vans are ideal candidates for e-beams, and North America is leading the charge in the pickup market. They are accounting for 40% of the total demand in 2037. It's clear that North America loves pickups and is getting into an interesting market with some modern new players like Rivian, for example, Scout, and Slate Auto, apart from the conventional OEMs. So just to conclude my participation, we have examined the dynamics shaping North America, the electric motor situation, from the impacts of the Trump administration policies to the evolving role of Mexico as a manufacturing hub. So it's clear that while challenges exist, uh, particularly in trade and tariffs, there are also significant opportunities for growth and innovation. So as we move forward, collaboration and adaptation will be key in navigating this evolving market. Thanks for your attention, and I'm excited to pass the conversation to my colleague, Kartik.
Thank you, Daniel. Hello, everyone. My name is Kartik Ganesh. I'm a principal analyst working on supply chain and technology at S&P Global. So I'll take you through the European market and how things are evolving in this particular region. Let me start off the discussion by talking about, say, the e-motor production on the whole. So as my colleague briefly explained, we have 3 recent forecasts which we compared and wanted to put forward and indicate to you how the market is evolving. Now, when I talk about Europe in particular, in November 2024, there was a projection of about 13 million units for 2025, uh, with an optimistic climb of up to 22 million units by 2036. However, since a few changes have come about in the global scenario, there have been a few revisions that came in. And in the first revision, there was a downward adjustment, which reduced the estimate to about 11.8 million units. This was primarily attributed to a more cautious stance amongst the OEMs and the suppliers due to the evolving market dynamics. And by August of 2025, the focus was further adjusted, where a decline went down to about 11.2 million units. This again indicated challenges in BEV uptake. While these figures are below the initial projections we had in the very first forecast, the long-term outlook for e-motors production in Europe remains positive. There is a gradual upward trend expected in the subsequent years, with 2037 accounting for about 22 million units. So there is almost a convergence that comes about with the recent forecast when compared to the older projections. In summary, despite immediate challenges, the industry is positioned for recovery and growth as it adapts to the changing conditions. Now, let's look at the regional breakdown of e-motor exports from Europe. When we compare these 3 forecasts, we see that exports to China have witnessed a significant decline dropping from about 220,000 units in November of 24 to about 132,000 units in August of 25. This raises questions about the competitive pressures that exist in that market. Similarly, North America also shows a striking drop in terms of the amount of motors that are brought about into the region from Europe, dropping from about 1.5 million units to about 925,000 units in 2025. Although the region over time is expected to have a peak in terms of import, but post 2029, we expect a conservative decline to come into play. Meanwhile, regions such as South America and South Asia are on a growth trajectory, though the latest revisions indicates that a much higher export volume from Europe is likely to go towards South America than South Asia. In summary, Europe remains a key player in the global export market, and the data suggests that a need for adaptive strategies to navigate these diverse regional changes and opportunities that are arising as we see in this world. Now we address the common concern regarding supply chain constraints relating to rare earth elements. The industry has been shifting away from rare earth dependency, with the OEMs and suppliers exploring alternatives that utilize more common materials such as copper. As my colleague pointed out, the global penetration rate is expected to increase from about 14% in 2025 to 23% by 2037. And Europe seems to be leading the charge at this, where the numbers go from about 33% in 2025 to about 52% in 2037. So externally excited synchronous motors dominate this segment. And when we talk about this segment in particular, they take up about 63% of the market share there in 2025. And this is expected to go as high as 76% by 2037. Induction motors are also gaining traction, with market volumes projected to quintuple by 2037. This shift in technology choice underscores the industry's commitment to sustainability and resource efficiency as it adapts to the changing technologies that are needed to make sure the electric vehicle market can boom forward. Now, another bit that we'd like to examine and put forth is the drive systems for electric vehicles. We do see a clear distinction between primary and secondary drive sources. We observe that induction motors will continue to play a significant role as a secondary drive because they are valued for their reliability and cost effectiveness. Meanwhile, electrically excited synchronous motors are anticipated to emerge as the leading choice for primary drives. This is driven by the advancements that these motors have made in terms of performance, making them competitive with permanent magnet synchronous motors. This transition actually reflects the industry's broader commitment to sustainability. By prioritizing research and development in EESM technology, manufacturers are able to position themselves at the forefront of electric vehicle market. Let us explore another advancement. This particular advancement talks about winding technology, particularly the rise of hairpin technology in electric motor production. Hairpin winding is gaining traction due to its high performance and cost effectiveness, making it the preferred choice of winding technology that a supplier or an OEM opts for. As the demand for e-axle applications grows, Europe is expected to see a rapid increase in the number of hairpin production lines that are existing in this region. By 2037, hairpin technology is projected to account for about 70% of the stator winding market, highlighting its significant importance. The number of suppliers producing hairpin winding is expected to increase by 1.5 times when we compare the number of players in the market in 2025 and 2037. Those focusing on continuous wave winding are expected to increase by fivefold. This indicates how suppliers are now starting to look at this more efficient and more powerful technology as a go-to technology. Similarly, players who were operating in the insertion winding market at this point in time, about 50% of them will no longer be engaged in producing insertion winding when we go into 2037. These shifts indicate a clear preference for hairpin technology, and we believe this particular technology is set to reshape the future of electric motor production in Europe. Now let's consider the implication of these technological advancements on copper demand. We've done a couple of scenario analysis just to give you a glimpse of how things are likely to evolve with these technological changes that are coming about. The growth of hairpin production and ESM motors is expected to significantly drive the increase in copper usage. By 2037, we believe e-axle motor copper demand is projected to exceed 157,000 tons. And we've added another scenario on top of this, where if all non-Chinese e-axle suppliers that are in Europe were to transition to ESM technology, the copper demand would surge by about 35%, reaching about 213,000 tons. So this basically gives us a very good glimpse of how big a critical role copper plays in the industry, while the industry tries to shift away from topologies that do not make use of rare earth elements. These new technologies underscore the need for strategic resource management for each of the suppliers and the OEMs. Now, continuing on to copper demand in another scenario, apart from the initial e-axle demand, if we were to think of a scenario where all-wheel drive vehicles and four-wheel drive vehicles make use of, say, non-rare earth based motors such as EESMs, then the amount of copper demand would increase by another 13%, equating to about 21,000 tons by 2037. And on top of this layer, we've added another scenario where we wanted to consider the fact that maybe A, B, and C segment vehicles that make use of electric motors that are rated below 100 kilowatt, if these motors were also if they were to also switch to a technology that does not make use of rare earth elements, then the copper utilization or the copper requirement would further increase by another 8,000 tons. These projections emphasize the importance of strategic planning in electric vehicle sector. By addressing these challenges proactively, the industry actually can ensure a sustainable transition towards greener technologies, benefiting both the manufacturers and the consumers. Finally, let's discuss advancements in e-motor speeds and their implications for the electric vehicle market on the whole. The trend towards high-speed motors enhances vehicle efficiency and performance, and underscoring Europe's leadership in sustainable mobility. As you see in the chart on the left here, the projections indicate that the penetration rate for high-speed motors will rise from about 5.3% in 2025 to about 29.1% by 2034, and it stays relatively flat post that. So this is much higher than the global penetration we expect of about 17% in 2037. This growth aligns with Europe's sustainability goals. It is driving manufacturers to innovate and meet consumer demand for cleaner transportation solutions. As European OEMs invest in high-speed motor technology, they position themselves at the forefront of electric vehicle market, enhancing their competitive edge. To summarize, advancements in e-motor speeds represent a pivotal moment for the industry because this drives the evolution of electric mobility and contributes to a much cleaner transportation ecosystem. Now I would like to hand over to my colleague Michael, who will take you further into what's happening in the region of Greater China.
Thanks, Kartik. So yeah, let's try and explore what's happening in Greater China over the next 10 minutes or so, because I think it's always a question that comes up. You know, the dominance. We've heard a little bit about the rare earth theme running through this, and yeah, some of the technology advancements that they're pressing on with in the region. So I touched upon it at the very start in that global overview, which was this emergence that we're seeing now of range extender. So Daniel touched a little bit on the e-beam technology. It's another one where range extender could emerge in the US potentially for towing capability and the towing capacities that you can get with a range extender. In China, though, the range extender is really beginning to take off. This year in 2025, it's going to be about 8% of e-motor production will be for a range extender vehicle. That's going to grow to about 13% by the time we get to 2037. If we look at the other propulsion types or the key propulsion types, you can see sort of a diminishing return for, say, full hybrids, so more moving towards plug-ins, battery electrics, the growth of range extender in China. This year, Greater China will occupy just shy of 50%, so 47.3%, of all motor production globally will come from Greater China. Daniel of Kartik have touched a little bit on some of the imports in the regions that are going to come from Greater China, particularly in Europe as we move forward. And to put it into context, everyone asks, are we moving towards a fully electrified world? How is each region going to do it with policies and everything else? By the time we get to 2037, 83.5%. So very, very close, very high numbers. 83.5% of all Chinese production will be electrified. So it will be either a battery electric, a mild hybrid, a plug-in hybrid, a full hybrid, a range extender. 83.5% China is heading towards by the time we get to 2037. Consumer sentiment, price, policies, legislation, everything that came from that consumer survey, all things that are being addressed as they move towards this market in China. So we've got all of these motors being produced. Where's the investment coming? Who's going to win out of this when we look at it? And what we tried to break it up here in terms of is the domestic v the non-domestic. So, a domestic OEM or a supplier, a Chinese domestic supplier, it's a BYD, it could be any one of the magnitude of suppliers they've got, or a non-domestic, so a Western supplier, a Western OEM manufacturing there. And you can see the split that we've got in 2025. It's diminishing returns in terms of e-motor production for the non-domestic suppliers and OEMs in China. And it's not going to really see any much more improvement as we look over the next, and I've done this out to 2034, the next 9 to 10 years. A slight uptick, a very small uptick, and in particular, someone like Tesla and their plans in China drive a chunk of this. It's the domestic OEMs, the domestic suppliers that are really going to see this ramp up of growth, going from about 22.5 million in 2025 to in excess of about 40 million by the time we get to 2030. Big investment plans coming. They're keeping the cost of those machines down. And we're seeing other regions begin to come in and use that, begin to leverage that lower manufacturing, lower cost price of these motors, particularly as Kartik touched upon in Europe. We're heading towards that 2035 ban. 2030 CO2 numbers, the cost is coming down. We're seeing some of the low entry platforms move towards Chinese production in some of these emerging regions and key regions as well. And where are those motors going to? So I touched upon it a little bit there. Europe, you can see this emergence of the exports that come out of China. Where are they going to? Europe, as it stands this year, about half the volume of South Asia. So South Asia, where they've got a couple of facilities, South Asia is where most of the motors this year for 2025's production are going to. But look at that big uptick we've got coming next year in 2027. And then the big ramp up we've got coming from 26 to 29 in Europe. That's as we head towards the CO2 targets that were the 3-year average, 25 to 27, but particularly heading towards 2030 numbers now, particularly heading towards that bigger fleet CO2 reduction that's coming. These lower cost Chinese motors really helping to bring the cost of those EV downs. Go back to the first slide. Too expensive. The cost needs to come down of these vehicles. South Asia remains, South America, the emerging markets of the two remain really real opportunity, for the Chinese suppliers to produce and offload some of the manufacture in China to these regions. But it's really that uptick that we're going to see in the next couple of years in Europe to highlight here. So they have ambitions within China in terms of production. They have ambitions outside of China from a vehicle production and vehicle sales, but we'll focus on vehicle production here. We won't go into the exports of vehicles. We've done the exports of motors. This is how they're going to do production outside of mainland China, we think, in bigger volumes, let's say. Not exclusively, but this is one of the ways in which we see it. So full vertical integration. We're looking here at the system, so the e-axle or the drive unit, the motor assembly, the inverter, and those two subcomponents we focused on at the start, the rotor and stator. In China, it's one supplier, and 21 OEMs have full vertical integration of that. They can produce all 5 of those components. Excuse me. The ambition outside of mainland China currently, between 2025 and 2037, so in a 12-year span, 285 new nameplates or models will be produced outside of mainland China. That's a big ramp up from where they are today. And it accumulates to about just over 22.5, so 22.6 million vehicles being produced outside of mainland China in this 12-year horizon. How are they going to do that? So there's 3 fundamental ways in which they could do it. They can go and look for local suppliers in all of these regions. It could be Europe, South America. Okay, but cost is still king. So do you really want to absorb some of the extra cost that you've got from European production? They could go and produce themselves in Europe. Okay, it's a potential option, but the speed at which it's going to take to get a vehicle plant in line and then a component production plant for a motor and an inverter and a rotor and a stator all up and running, very costly and very time consuming as well. And these ambitions, you can see the time frame, time horizon we're looking at here, it's going to be a ramp up relatively quickly. The other option, and we touched upon it there, keep producing in China. And this is the big emerging trend we've seen in the last 12 or so months. X-in-1 is now a real buzzword, increasing levels of integration onto the drive unit. If we break it down at a global scale and then break China versus excluding China. So we see Greater China, this X-in-1, the purple bit there, it's about 22%. So really this is being driven this year by BYD and their 8-in-1 system. It grows to over a quarter of the motors produced in China will be used in some form of X-in-1. Now that goes up to a 12-in-1 with the new BYD systems. Could be an 11-in-1 with the InfiMotion system, and a few others that are emerging in there from 5-in-1, 6-in-1, 8s, like I say, all the way up to 12. There is talk of going to 16 to 20-in-1 systems. Let's see. There probably is going to have to be a line drawn at some point. Fundamentally, the aim here is to keep this all integrated into one unit, keep the technical R&D in China, and then export it out to the vehicle plant on one pallet, similar to what we would do with an engine and transmission assembled in a plant. It ships to the vehicle assembly plant, quick, easy assembly, and out the vehicle drives. Outside of China, you can see it's really small. It's about 4% by the time we get to 2037. What we're seeing is the parallel bit to this is it has focused minds on integration. It has focused a lot of suppliers on where they can gain the cost benefits, weight benefits, packaging benefits of integration. But generally on the e-axle, at least, we're set on 3-in-1s. It's about 3/4 of e-axle production by the time we get to 2037. And the 2-in-1 predominantly a lot of PHEV and a bit of other ones. But it's the integration outside of the drive unit that we're seeing, the integration of power electronics, the integration of the battery management systems, the thermal management. We are seeing a much more increasing trend outside of China to still integrate, but not integrate on the drive unit, to keep your supplier base a bit more diverse across the different components, and then integrate, say, the power electronics separate to that 3 or 2-in-1 drive unit that you've got. And winding technology. Kartik touched upon the winding technology that we're seeing in Europe, and we're seeing it globally, the real emergence of hairpin. You touched a little bit on S-Wave. China, we are really starting to see the emergence of new technologies, really trying to drive the innovation scale here. So this is in terms of a platform count. So Kartik did it in terms of a supplier count. This is the number of platforms using it. It's still reasonably small volumes as we see the emergence of these, how the manufacturing processes work, how the quality works. The emergence of S-Wave, 20 platforms in China by the time we get to 2037, but it's the other two. Mini pin, this one that's been emerged in the last couple of months. We've seen it at a couple of the trade shows and shows in China this year. And then X-pin, this one that's been developed by predominantly UAES to begin with. Really big growth in the second part of this forecast horizon as we get into the next decade. It eclipses S-Wave in China. It grows to about 30 platforms it's going to be used on by the time we get to 2037. And don't expect that to grow as more and more suppliers use it, as the quality's proved, tooling costs maybe come down. Greater China is really beginning to lead the way on these emerging winding technologies that we're seeing as an alternative to hairpin, which is really going to see that big growth in most regions anyway. So a very quick summary from me as we approach the 3/4 of the hour. So the global traction motor market, it will grow from about 59 million units this year to over 130 million units by the time we get to 2037. Like we said, from this time last year, we've added about 8 million more motors to that top line with the emergence of some of the complex hybrid systems at a global scale. Consumer sentiment towards electrified vehicles, so even hybrid this year, is continuing to diminish. The sentiment is not improving let's say ever since 2021. Range, charging experience, the whole package of charging, and cost still the big lingering issues among consumers and their willingness to make the switch toward electrified vehicles. The United States, Daniel touched upon it, some really big significant political and consumer shifts in the past 11 months, ever since the emergence of the Trump administration. The industry is beginning to settle down there, though. If you look at those numbers that Daniel showed from the sort of April to August, the tariffs has had an impact, but the longer term trajectory is beginning to settle down. One thing we are hearing from suppliers, that longer term clarity. Now, I touched upon the investment that they're hoping to get, establishing a long-term path, some longer-term clarity in the United States, and then I think we will start to see some more investment come, particularly, and Daniel touched upon it, the Japanese suppliers, particularly seeing those maybe begin to put a bit more of the more than already planned investment, let's say, into the US and North America. And Greater China is at the forefront of innovation and development. They work on integration, they work on winding technology, the ramp up that they've had, particularly in the last couple of years in terms of the production volumes, the policy legislation all heading towards electrified vehicles. So Greater China really taking the lead on this, and we're beginning to see some of these even established markets, particularly Europe, begin to lean on some of the suppliers there for technology and cost. On that note, please do contact us. The slides will get shared afterwards, I think. But yeah, we've got some time. So any questions, please do put them in the chat.
Thank you. Thank you for such an insightful presentation. The information shared today is highly valuable and relevant. As Michael just mentioned, the presentation slides will be available for download from our website. We'll now move to the live Q&A session. I would like to encourage our audience to submit their questions in the comments. To begin, I have a question of my own. With range extender volumes emerging in Greater China, do we expect any other markets to explore and adopt this technology?
Yes, but I would say we've got a big eye on just how big that will be elsewhere. So at the start, I sort of briefly mentioned the bit with the range extender is it flip-flops the PHEV. The much bigger battery size you have and that smaller engine as the generator, it eliminates, as it says on the tin, range anxiety, eliminates a lot of the charging issues, but it fundamentally gives OEMs the chance to use some of these battery platforms that they've developed in other ways. If people don't want to move towards battery electric, you can bring the cost of the battery down slightly. You don't need quite as big a battery pack, but you can still develop use the bigger battery technology you've developed. North America is the big one that we've got our eye on. There is an emergence of it in Europe potentially. There's a few OEMs mentioning it. North America is really the one that's the market that we've really got our eye on as to where range extender volumes could pick up. And I touched upon it at the end there. Probably once we see a little bit more, the industry's beginning to settle down. Once we get a little bit more of a longer term trajectory there, I think we will see how big range extender could possibly be in North America.
Yes, thank you, Michael. And I have a couple of more questions. I think we still have time. As airpin winding technology is projected to account for around 70% of the stator winding market by 2037, what strategies should manufacturers adopt to effectively scale up production and ensure quality while transition from traditional winding methods?
I'll take that up. So that's actually a good question. So in order to effectively scale up hairpin winding, there are a few strategies that say manufacturers should try to say dive into. So the first one would be to try and invest in advanced manufacturing technologies and automation as a whole, because this improves the production efficiency and consistency significantly. The second would be to try and say forge partnerships, because we've seen a few suppliers who have say either acquired or have collaborated with some players who produce say just production lines for winding technology as well. So what this basically does is protects them in terms of availability of equipment and availability of say the necessary setup when it comes to the production of electric motors. So these say strategies will help them meet the say growing demand for hairpin technology, but also maintain, say, high standards of quality and performance when it comes to the production of electric motors.
Perfect.
Thank you, Kartik.
Yeah, sorry, Alexandra. One that's just came in here. So yeah, I think probably for both of you, Kartik and Daniel, I think, and I can jump in if I need to. But I think that you touched upon the emergence of rare earth. Really, two different paths emerging in North America versus Europe. Why is that? Why are we seeing those two different trajectories, particularly on EESM?
Speaking about North America, the thing with rare earths is that North America has never been a production hub or manufacturing or process hub for North America. Sorry, for rare earths. So they are starting to put some lines together in the region to produce magnets. However, the quantity and volume of these ones, I mean, we are still not sure if we are gonna hit the volume targets needed or satisfy the volumes needed. So they are starting to that's why they're trying to OEMs are starting to find another way around of rare earths. And I mean, I think in this point, induction motors will be a key player, and also ESM induction motors because they are the cheapest of the technologies. I mean, we have been having induction motors around for a lot of time now in other applications, and obviously ESM will bring us the performance needed. For example, on towing capabilities, it's not there now, but ESM technologies are trying to stand up against PMSM. But yeah, basically that's the difficult part for North America, is that they don't have the volumes or the manufacturing here in the region, so they are struggling because of the supply chain. Kartik, do you want to add something?
So if we speak about Europe in particular, so it's always been a case where induction motors were touted against, say, permanent magnet motors, and we do know induction motors had certain shortcomings when it came to performance and, say, efficiency, where in particular for electric vehicles. So what that drove is innovation in Europe, which led to suppliers and OEMs trying to explore a new topology. That's where EESM crawled in. And then off late, EESMs have seen quite a significant, say, investment and development, such that they've more or less reached the levels of permanent magnet motors. So that's the reason why EESMs have become more of, say, go-to choice in Europe than induction motors as a whole.
Yeah. Yeah, so actually there's been a comment here about how synchronous reluctance motors will compete with the ESM. I think to pick up on what Daniel Kartik said and to try and sort of answer that one, yes, there's an emergence of varying technologies right now. ESM, as we speak, is the one that seems the most ready for people. It's the one that people have got, and it's emerged. The performance is really comparable to permanent magnet these days. Even on a cycle, there's a question mark as to whether it's even better. There is a slight on cost, but the big word there is risk. And I think it's that risk in the supply chain. In the US, I think maybe there's a hope that there's a bit less risk. They can produce a bit more of the rare earth themselves. They have an abundance of it in particularly Alaska of the materials. And there is an emergence there of maybe some of the non-rare earth based magnets coming. A company like Niron Magnetics looking to maybe make waves in that market as well. So we do have our eye on the synchronous reluctance, but I think at the minute ESM is really the big emerger, but we don't rule that out coming in. Say, we touched upon the sort of niche winding technologies that are emerging in China. I expect some niche technologies to emerge that try and establish a de-risk of the rare earth supply chain here.
Perfect. Thank you, Michael. I don't see additional questions from our audience, so I would like to thank you three for an excellent presentation. I trust our audience gain valuable perspectives from today's discussion. A big thank you as well to everyone working behind the scenes whose efforts made this webinar possible. As mentioned earlier, the recording will be available on demand on our website. I'm also pleased to announce the call for papers will open soon, and this is your chance to take the stage at CWIEME Berlin 2026, taking place from the 19th to the 21st of May. I look forward to receiving your submissions and to seeing you all at the next CWIEME Talks. Thank you, everyone.